Okay, in this video we're going to look at calculations of bounds. If you've missed the last video, which was on upper and lower bounds, please watch it so you know what's going on. Okay, so calculations of bounds. When performing calculations with quantities that have been rounded, it is crucial that you identify the upper and lower bounds of all quantities before you do any calculations. So finding the bounds after calculation will give you a completely wrong answer, so it's important that we work out the values of the bounds beforehand. So when a calculation involves adding rounded values, the upper bound of like a plus b, so if you have two values, a and b, and you add them, so the upper bounds of a plus b would clearly just be the upper bound of a plus the upper bound of b. And the lower bound of a would just be the upper bound of a, the lower bound of a plus b would be the lower bound of a plus the lower bound of b. So dead easy. So for the upper one, you just take both the uppers. For the lower, you just take both of the lowers. So that's dead easy. Whenever it involves multiplying, but it's a wee bit different. So the upper bound, when it involves multiplying as well, it's going to be the same idea. It's going to be upper bound of a times b is upper bound of a times the upper bound of b. The lower bound of a times b is going to be the lower bound of a times the lower bound of b. It's a wee bit different if they're being subtracted. You need to think a wee bit more about it, but I think for this video we're just going to look at the upper bounds of a plus b, upper and lower bounds of a plus b, and upper and lower bounds of a times b. So in the first one here, this example says c is equal to 0.4 to 1 decimal place, 0.40 to 1, c is not equal to that at all. C is equal to 4.0 to 1 decimal place, and d is equal to 2.4 to 1 decimal place. Work out the upper bound and the lower bound of c plus d. So here, just say we're just going to say the upper is equal to, and then lower is equal to. So the upper, first of all, you're going to take the upper of c. So the upper value of c is 4.05. So remember how we get that. It was the it was 1 decimal place it had been rounded to. So 1 decimal place is 0.1. So that means you go plus or minus half of 0.1, which is 0.05. So that's how we've got our 0.04. So you've added 0.05 onto our 4.0 to give you 4.05. Same idea for the d. D is 2.4, and that's the 1 decimal place. So you have to go plus or minus 0.05 onto the 2.4. So my upper bound is going to be 2.45. And when you add those two things, you're going to get 6.5. Bang on, 6.5. Okay, for the lower bound, it's the same idea. So first of all, the lower bound of 4.0 is, so you take away 0.05, you're going to get 3.95. Likewise, the lower bound of 2.4 is going to be 2.35. And if you add those two things, you're going to get 6.3. Okay, same idea for c and d. C times d, so we'll just write down upper equals, and we'll write down lower equals. So for the upper bound, it's multiplying. So it's just the upper bound of c times the upper bound of d. And we'll work that out. And if you work that out in your calculator, you'll get 9.9225. Likewise, for your lower bound is going to be 3.95 times 2.35. And again, if you do that on your calculator, you're going to get 9.2825. Okay, this example says a rectangle has a length of 12.8 centimeters, correct to the nearest millimeter, and a width of 64 millimeters, correct to the nearest millimeter. So work out the upper bound of the area of the rectangle and give your answers in centimeters squared. So first thing I'm going to do is convert. So I've got 12.8 centimeters, that's fine. And I have 64 millimeters, which is the same as 6.4 centimeters. So I've converted that before I've done anything else. So it was to the nearest millimeter. So the millimeter is 0.1 of a centimeter. So we're going to have to go plus and minus half of 0.1, which is 0.05. That's what we're going to have to add on to each of these, because they're both correct to the nearest millimeter. So I'm going to have to go plus or minus of 0.05 of each of these. Now it says in the question we want the upper bound. So we're going to give the upper bound. I'm actually going to give you the lower bound as well, just for the completeness in your notes. But for the upper bound of it would be 12.85. That's the upper bound of 12.8. And the upper bound of 6.4 centimeters. The upper bound of 6.4 centimeters is going to be 6.45. And if you multiply those out, you're going to get 82.8825. And I've actually given my answer to one decimal place. So it's going to be 82.9 centimeters squared. Actually, I've not given it one decimal place. I've got it 3 sig figs, which happens to be the same thing in this case. Okay, not asked for, we'll just say not asked for, but this is just to show you anyway. Your lower bound would be, so the lower bound of 12.8 would be 12.75. Your lower bound of the 6.4 is going to be 6.35. And when you multiply those out, you're going to get 80.9625. And again, I've given it the 3 sig figs. So why I want to do this one was it's a very interesting 1 to 3 sig fig. So if I'm going to give this to 3 sig figs, let's investigate this one. My first significant figure is my 8. My 8 would be the first significant figure. My 0 would be my second sig fig. My 9 would be my third. So we'll get rid of those. And my check figure then is my fourth one, which is my 6. Now because this 6 is 5 or above, greater than 5, I round up my 9. So my 9 rounds up to a 10 effectively, which means that this next 0 here I'm talking about, it also rounds up to a 1. So it is 81.0, and that is to 3 sig figs. So 81.0, I'll squeeze in my, centimeters squared to 3 sig figs. So I think it was worth showing you that way example, as that's a tricky one which people would get wrong. So if they wanted the answer to 3 sig figs, as I've given you here, if you had written 81 centimeters, because the third sig was a 0 and you thought I could get rid of the 0, 81 would be wrong. If you look at 81, you've only got 2 significant figures, so there's no way that could possibly be 3 sig figs. Whereas this one, you've got 1, 2, 3 different figures, so you have definitely got 3 significant figures. Okay, you're now ready to do your practice book, page 22, questions 2 to 20.